Students, let me start with yesterday class continuation. So yesterday class we derived up to here. What is the efficiency of the Carnot engine? Eta is equal to 1 minus 1 minus T2 by T1, this value. So this is nothing but this value is nothing but Q1 minus Q2 divided by Q1. So here also we will write here T1 minus T2 divided by T1. This formula we arrived here. The yesterday class we already arrived this one. This value is nothing but total work done divided by energy of absorption. Energy of absorption. This formula also we arrived. So in this one, you can get the some of the conclusions here. How you get the conclusion means let me check this formula. So the formula what I am taking here, eta is equal to I am taking T1 minus T2 divided by T1, where T1 is equal to temperature of the source, temperature of the source. I am taking here T1 is equal to temperature of the source. Here T2 is equal to temperature of the sink. It is the temperature of the sink. So will you please observe here, this formula is independent of the parameters which are depending on the parameters which are depending on the material, the substance or working substance parameters. That means the eta is having only the T1 and T2 terms. One is there. So I am taking in the simple manner. Eta is depends on only on T1 and T2. T1 and T2 means the efficiency of the Carnot cycle will depends on only the source temperature T1 and sink temperature T2 only, and also we will tell that we will conclude that it will independent of the nature of the working substance. There is no any values of nature of the working substance here. So the eta is independent of working substance. So these two words will tells that these two sentence will name it as the Carnot theorem. So let me write the Carnot theorem. The conclusion of the eta in the Carnot cycle will give the Carnot theorem. Let me write the Carnot theorem. So the Carnot theorem will tells that the first one, the Carnot theorem will tells that the efficiency of the Carnot cycle, the first it will tells that, and two sentence. The first one, the efficiency of the Carnot cycle will depends only on the T1 and T2. That means it depends only the efficiency of the Carnot cycle. The efficiency of the Carnot engine depends only on the source temperature T1 and sink temperature T2 and sink temperature T2. This is the first sentence, and second sentence what I am telling that so the Carnot heat engine heat engine efficiency is independent of nature of the working substance. Nature of the working substance. This is the very important theorem. So the conclusions of the eta is arrived to the theorems of the Carnot theorem. So that is the important one. Now let me move on to the another topic. What are those means? If you see these, we already completed the heat engine efficiency eta. We already know that one. Heat engine efficiency efficiency, neta is equal to we already know this one, T1 minus T2 divided by T1, or we are having the Q1 minus Q2 divided by Q1, otherwise we have the total work done divided by Q1. So where Q1 is nothing but here is the Q1 is equal to, let me write what is here. So here is the Q1 is equal to energy absorbed. So where Q2 is equal to energy released, where W total is equal to total work done. So the total work done, where T1 is equal to source temperature, where T2 is equal to where sink temperature, it is the sink temperature. So these are the formulas we are having in this one. So let me write side by side. We know the coefficient of the performance of the refrigerator. So the coefficient of we have the coefficient of performance of the heat engine. So performance of heat engine, refrigerator, performance of refrigerator. So this is the what is the formula? Just recalling that one, what is the coefficient of performance of the refrigerator? It is having the beta is equal to, we have the formula, what is that one? Heat extracted from sink divided by work done on the system. These are the formulas we are having. Let me write in the formula manner, that is equal to Q2 divided by work total on the system. You should be careful here, work is doing on the system. Otherwise we have the another formula for this one, Q2 divided by Q1 minus Q2. So this is the formula is there for the beta. So let me fix this one. So now the second law of thermodynamics will tells that we are in the second law of thermodynamics. So it will tell that the limitations of the efficiency of the heat engine and the coefficient of the performance of the refrigerator. The second law will tell that the second law of thermodynamics will tells that what will tell. So the limitations of it will tell the two types of limitation. The first limitation is the limitation of efficiency of heat engine. The limitation of efficiency. So it will tell that the limitation of efficiency of heat engine. It will tell the efficiency of the heat engine. So it will tell the efficiency of heat engine, and the similar manner it will tell that the limitation of coefficient of performance of refrigerator. Coefficient of performance of refrigerator. So these two values, so they will give the at what limit we can do this one. This value will tell that. Will you please look on this one? So now so that means it will tell about the heat engine. Otherwise it will and also it is telling that about the refrigerator also. Now how can we define this one? Well, you please look on this one. What is there here? So neta is equal to this value we are getting. So will you please look on this one? So what is this one? So it is the total work done. The total work done divided by total Q absorption. These values we are getting. So that means when we with this value, if I want to neta is the 100% means. So if you multiply this with 100 means you will get the percentage. So that means if you want to bring these 100% means that means when we will convert, so we will convert this value, we will convert this value, how much absorption of the heat energy is absorbed from the source, that must be completely converted into the work done. So but it is impossible. Will please look on this one. So let me start with the first point. We are concentrating on the first point. So first point is telling that about the heat engine. So that's why I am taking neta is equal to T1 minus T2 divided by T1 is this is nothing but V work done by total divided by Q of absorption. Q of absorption is there. So these value is I am going to take it as the percentage into 100 means here you can multiply with 100, here I am multiplying with 100. So when this value will be become 100, then T1 minus T2 is become as a T1 only. T1 minus T2 is become as a T1 only. Then only the T1 will cancel. After that we will get the 100% of the efficiency. But to become the T1 minus T2 is equal to T1, so T2 must be equal to the 0 Kelvin. So 0 Kelvin means what is the value of here? This is the minus 273.16 degrees Celsius. But this value is impractical to achieve this value is not possible. So it is very, very important. It is not possible to achieve this value. So that means in practical this temperature is impossible temperature. That's why the T1 minus T2 never will be equal to the T1 only. Then that work done, the total work done never be equal to the Q of absorption, which is absorbed from the source temperature. That means the neta in practical. That means in practical. So the in practical neta percentage is always less than to the 100%. So that means what is he saying? So that means some of the work is not converted, some of the heat is not, some of the heat which is absorbed from the source is not converted to the work. So that is it is indirectly saying that how much amount of heat is absorbed from the source, heat is not converted to the as a work. That is only telling that the second law of thermodynamics in one sentence. So in second law of thermodynamics it is having the two statements. One statement will relate to the heat energy, heat engine. Another statement will relate to the another statement is related for the refrigerator, that is the refrigerator. So that means it is telling that the statement is telling that no process is possible which can completely convert heat absorbed from the reservoir, from the source. We are taking from the source, from the source into work. That is only word we observed here and what we discuss up to now. So that means what I am saying. So if we observe some value, that value heat energy 100% may not be converted into the work. It is impossible. So that means that is only here is saying. So no process, any process is not possible. If we take n number of process also, it is not possible which can completely convert heat observed from the source into work. This statement is given by the was given by the Kelvin and Planck. So Kelvin and Planck. This statement was given by the Kelvin and Planck. That's why these definition is named as the Kelvin and Planck definition. Kelvin and Planck definition or Kelvin and Planck statement. This statement is named as the Kelvin and Planck statement about the heat engine. So this is about the heat engine formula, heat engine definition. Now if we go to the another one, the second law of thermodynamics is the two sentence. The first sentence is the statement is related for the heat engine. The second statement is related for the refrigerator. So what is the refrigerator limits? It will tell the limits. So refrigerator beta is equal to will you please repeat? So the beta value is equal to it will having the Q2 divided by Q1 minus Q2, that is equal to heat extracted divided by heat extracted divided by so work done. So what we this beta, the beta is nothing but it is the coefficient of the performance of the refrigerator. So if we want to increase this value, so up to which value we can increase? This value can be increased for the infinite. Infinite value means to become this beta value infinite. So to become otherwise to beta is, so beta is equal to infinity when it will infinity when work done is equal to 0. When work done is equal to 0, beta will go to the infinite value. Then work done is equal to 0, beta is going to infinity means so that means it is saying that beta is equal to infinity means Q1 minus Q2 value is equal to 0. Q1 minus Q2 is equal to 0 means it is indirectly saying that this value is equal to 0 means so what will happen? So heat is extracted from the source. What is it is telling that? Let me take the refrigerator diagram. So in the refrigerator, it will take from the sink to Q2 heat energy. So by doing the sum of the external work on the system, it will release the some amount of Q1 heat energy to the sink, to the source. So this is the block diagram for the refrigerator. So where it is a beta is infinity happening, so this value is going to be 0. That means without doing some work, some of the heat energy is transferring from the lower temperature of the sink to from higher temperature of the source. But it is telling that it is impossible where the low temperature of the sink it is impossible to transfer the heat energy which is having at low temperature of the heat to high temperature of the source. It is impossible without doing any work here. That means to transfer these, at least we needed some work need to be done on the system, then only it will transfer. Without this work, it is impossible because of we need to perform this work some value. That means this value never will be come to 0. That means what I am saying, indirectly it is saying that no process is possible which can transfer heat from a lower from a sink which is having cold body sink to source which is having hot body it is a hot body without doing any external work, So this is the definition. So it is about related to the limitation of the coefficient of the refrigerator. So that means coefficient of the performance of the refrigerator. So that means to become the beta value is infinite, we need to W must be 0. So W never will be 0 because of it is telling that limitation of the coefficient of the performance of the refrigerator. This statement is given by the class S. This statement is given by the class S statement. We will name it as the class S statement. So this is the class S statement. So that means these two statements are named as the thermodynamic second law of thermodynamics. Once again recall this one. The second law of thermodynamics is telling that the limitations of the coefficient of efficiency of the heat engine, and also it is telling that the limitations of the coefficient of the performance of the refrigerator. So the first law is the first statement is given by the Kelvin Planck statement. So that means no process is possible which can completely convert the heat absorbed from the source into work. That means some energy must be transferred to the lowest temperature of the sink. That is the one statement. The second statement is the class A statement is telling that no process is possible which can transfer heat from the sink, that is the cold body, to hot body without doing any external work here. Without doing any external work, this statement is given in the class A statement. These are the two statements which can come into the thermodynamic second law of thermodynamics. Let me stop here. Tomorrow we will meet.